finally get the chance to do another test. On test today we have GRP end caps made in a 3D printed mould. These ones have all been made in a high impact polystyrene mould, dissolved with acetone and with heat, and kind of picked off and peeled. Kind of worked alright. I think PLA would be a better option, just boiling it and then just peeling it off. I didn't have it loaded. And at the end, to get the dimensions right, what I've done is just scaled the whole print by 1.4%, so it's 101.4%. The size it's meant to be, I don't know where the size discrepancy is coming in. This is just to blank off the hole there. And we also have this beast, the Makita DTW 450. Kind of overkill. That should crank down these bolts nice and tight on the O-ring, car tire O-ring thing. Should be good. And we reinforced the front of the test chamber just with like 5mm by 40 flat bar. I had to cut it here and here and then build it up with different sections. Don't account for the bend that is developed. It would have been a lot easier to do that before it bent. But high hopes. Probably without that flex, the O-ring is going to stay in contact and these bolts aren't going to be stressed by a kind of bending moment as the front plate bends. And we should be good at up to 40 bar. That's the hope. We might even get an improvement if these end caps hold out. I'm not sure. There might be issues with the end caps. There might be capillary action down the fibres of the GRP. All the fibres were exposed, so I'm not sure about that. And testing the one on the left, the top left end cap is a plastic, low density polyethylene. I think that one was. It didn't have quite the same compression on the O-ring as the other GRP ones, but just testing the idea of the bolt running through. So before I think they were failing because the bolt running through was meeting the bolt from the other side. As the end caps compressed, the seal on the back was released, and then there was no seal on the inside. So this has seal on the back and on the inside. And I thought might as well test it out. Mounted horizontally this time, so we get more information. You know, if one end cap fails and then the other one, we can see where it fails. Rather than just having a puddle at the bottom, and we don't know whether or not the other one's failed as well. Great. Test on. Yeah. Fucking in. Love this tool. Beautiful beast. Right, some more nuts and more nuts and the light power. Awesome! This is kind of exciting. Get everything in. We've got our pressure washer hooked up through the line up to the top. Lights on. The box still not logging the pressure. And GRP end caps on test. So we'll see what happens. Right. Coming up. Equivalent depth. Still nothing's failed yet. good. I think we'll hold it at like 100 meters equivalent depth for a while. Or 10 bar, and see what happens. I can go. Oh yeah. Endcap failed. The GRP looks like it's delaminated and pushed the cap in. Obviously, it was laid up with the discs of GRP in the mould, so that's blown that one. I guess just it's delaminated along a joint between the discs of top strand mat. So we can maybe try a random strand orientation, just kind of messing it up and jamming it in the mould. Everything else looks alright. Test chamber's good. Shaking like a shaky thing now. That's 100 meter equivalent depth, or 10 bar. And the chamber looks good so far. Brilliant so far. Just slightly around the pressure gauge nozzle. Popping up. Coming up to 200, 300 psi, 20 bar. 20 bar now. Success. Test chamber's working perfectly. A little bit scared. In theory, there shouldn't be too much energy stored in this system. You know, so the water's non-compressible. That's brilliant. Terrific. Oh! Wow. Something just failed. I wish I had the camera in there. Okay. Wow. End cap went. Wow, that is brilliant. How did the end cap go? Or was it? Bit of a crap test. I was too busy perving over the chamber not leaking. But that's an absolute result. Test chamber that would do 20 bar without leaking, which is awesome. And even crank it right up. And we got a failure. We didn't actually get the failure on camera, but we got a failure. Proper full power implosion. Looks like the end cap's pushed in and maybe that metal bar has cracked the acrylic when it crushed in. Wow, brilliant. Let's crack it up and see what we got. Ta-da! Results. Okay, victim number one. That was the wow. Wow, brilliant. That's quite impressive. Wow. So this is the, I was around that way in the test, the low density polyethylene melted down chopping board was good to about 200 meters, and then the plastics failed quite uniformly. It's not got layers or anything in it, and then it's been squashed into the tube so far, and then this piece of rod has punctured the acrylic on the other side and failed at the other side as well. Kind of made a ding in this end cap, but that end cap was good to 200. There's a mark there where I had the screw mounted in the jig. It's alright. Acrylic probably would have been alright beyond that if it hadn't had a bit of threaded bar shoved through it. And then, okay. I wasn't expecting that to go there. I was expecting this bottom lip to pop out, but I guess the O-ring spread the weight quite nicely, whereas the acrylic might have put pressure points on the plastic. You know, if the acrylic wasn't perfectly square. Might be more pressure on this side, and started to go, and off it went. There's no striation in the plastic either. Pretty uniform. It's just failed because the plastic's just not strong enough. Beyond 200 meters, and obviously this bolt through the end cap didn't appear to leak. I'll check the video. It didn't seem to leak until it failed properly. Keep end caps good. Oops, for this one, well, it has delaminated along the line. So one of them, I was wondering about when I was making these, how destructive the process of removing the mould was. So these I had in acetone for like nearly 2 hours to soften the polystyrene, high impact polystyrene. So it might have affected the strength of the GRP. But there's also I noticed small cracks when I was cleaning up the mould, which might have been because I'd added too much catalyst, or had the resin was too active, so it generated too much heat inside, and then just fractured, air bubbles, and fractured when it was still green, so it didn't have full strength. That's something we could work on. There's quite a few strands going through that, so maybe I'm tempted to say that's down to pressure of an overactive resin when it was curing. But it's got the weakest point round there, around the O-ring groove. Little crack there. Definitely promising. And that one's fine. This is one of the first ones I got dimensionally accurate enough to use. So it's fine. I didn't even clean the print up on this one. So I have been sanding the little ridge that occurs where the Z step happens on the 3D print. But that was, excellent results. I'll make something else to squash. And the chamber's good. Next time we'll crank it beyond 20 bar maybe, and actually see things breaking, which would be good on camera.